Hello everyone at DLN. I'm Aya, your network director, and I'm very excited to bring to you this fireside chat with Maarten van Roon, Chief Commercial Officer at Carbon8. Hi Maarten, it's really good to see you today.
Hi, Aya. Great to meet you. Thanks for having me.
Great. And just a brief introduction, Maarten has over 16 years of experience in commercial leadership across specialty commodity businesses, and he is, as I said, a chief commercial officer at Carbon8. Maarten, so perhaps you can give us a brief overview of your background. How do you come at this decarbonization debate? And also, what is it that you and your team are focusing on in Carbon8 at the moment?
Great. Yeah, absolutely. I'm glad to. So my name's Maarten van Roon. I'm Dutch national by background, but I've spent a majority of my life living in other countries, currently based in London, in the United Kingdom. Yeah, I've got a career spanning approximately 16, 17 years, initially across the oil and gas sector, up until around a year ago, working on deal making and commercial leadership functions, building businesses, expanding them in specialty commodities. And in one of my last roles within the oil and gas sector, I was exposed to working with a large amount of startups and looking at decarbonization ideas outside of the oil and gas major where I was working at the time, and had the opportunity and on the back end of COVID to immerse myself in the world of startups and decarbonization startups, and took the leap into heading up the commercial function and essentially accountable for growing the business across the business development, the sales and the marketing function currently for Carbon8 Systems.
Fantastic. Sounds really exciting. So now let's talk about maybe CO2 in solid form. The storage of CO2 in solid form, what does it require? What kind of trends or technologies are we seeing at the moment? And then we would like to learn specifically more details about Carbon8's technology.
Sure. Thank you. And so I think the sector that we're really talking about here is probably CCUS. So that is the carbon capture and utilization and storage. And the U is really, I think, what makes the difference there in terms of reusing materials for another purpose. And as a result, permanence in storage of CO2 in those solid materials. I think the great thing about that aspect of the carbon storage chain is really the circularity principle that it involves in terms of utilizing materials with carbon sequestered in them for another purpose and giving them essentially a second life. So you have both the aspect of the CO2, which can be sequestered in the materials, but then you have the additional sort of ESG benefit or value chain benefit of, again, not having to use virgin materials all over again, but being able to reuse the materials which now have carbon dioxide stored in them. And I think that's a fantastic trend, and I think it's vital as one of the pieces of the puzzle towards the decarbonization journey that certainly hard to abate industry is on.
Yes, and in terms of accelerated carbonation technology that Carbon8's offer,
yeah.
So do you take it directly from the source, or what else is involved in that technology?
Yeah, sure. I'm happy to speak for a few words around what we do. So Carbon8 Systems is essentially a CCUS scale up, and what we do is we essentially treat or use thermal residues, so industrial thermal residues that originate from usually the burning of something, and essentially use those materials and inject CO2 in them, and by doing so create a chemical reaction which allows those materials to be reused again. So essentially it has a few benefits in terms of what it offers to clients. It allows us to divert residues and waste materials that would otherwise be destined for landfills. So you have that part of the equation. You then have the direct capture of CO2 from production operations. So we are able to take CO2 directly out of the flue stack or the chimney of different industries, whether it's cement industry, whether it's biomass, whether it's energy from waste, steel, etc. And our innovation, which houses our technology, is able to directly capture the CO2 from those operations, inject them into or use them to react with the thermal residues on site, and what that reaction creates is materials with permanent storage of CO2 that can be reused again. And those materials are reused again either in the building industry, in the fertilizer industry, and quite a few others that we're in the process of unlocking as we go forward. So different benefits across the scale, but very valuable to customers. The technology, which you mentioned in itself, which is called ACT, which is where essentially the magic happens, stands for Accelerated Carbonation Technology. Carbonation is the reaction that we see in nature. We see it happen frequently. A great example, I think, is the limestone cliffs in Dover in the UK, where you see nature essentially sequestering carbon on its own. And what we've done is we've taken that reaction and accelerated it across a far faster space than it takes nature to conduct it, and hence why it stands for ACT, Accelerated Carbonation Technology.
That technology sounds fascinating and really great. So I hope our industrial members will be interested to learn more and be in touch with you. And now perhaps we could talk about the projects that you have, specifically maybe a project in France. What is interesting to learn more about the details of this project, but also how do you go about establishing trusts with the other parties, and what are some of the key challenges or key steps involved for both parties to undertake to make sure the project is going ahead, be it permitting or something else?
Yeah, no, that's a fantastic question. I think it's a challenge faced by all startups and scale-ups. Of course, we are a new business with, as a result, a limited track record, and therefore working with larger customers, larger industrials. You have a lot to prove in order to gain that trust. I think with us, one of the major things that really underpins our business specifically is that we sit on a very solid foundation of 20 years of science, which come out of a very reputable university, which is originally where the ACT technology was discovered. So that is in the Greenwich University here in the UK. So we sit on that bedrock. I think that gives us a certain amount of scientific credibility when we speak with customers. And then I think it's a series of steps really going through and proving points and taking people through stage gates. So you have to really have a process from the beginning towards the end. And in our case, it really starts with proving the science and proving to the customers that the science we have in-house is able to treat the residues that they have, and that we can demonstrate that we can, in a lab scale, actually do what it is that we say we can do. So that's what we've done in this case for our first really strategic commercial customer, which is in France, which is the Vicat Cement Group, who's the first to have taken the leap of faith, at least in a commercial sense, of adopting our technology, and has the intention of rolling it out across their sites in the world. So we went on that whole journey with them, all the way through to a pilot on site, and as a result, with all of those proof points, I think you take it really step by step, and you build that journey together, and that's worked really well for us. It's not gone without its challenges or without its hiccups or mishaps, but I think that's very much in the nature of a scale up and a startup organization.
Mm-hmm. Yeah, that's fascinating to hear. And perhaps we could talk a little bit more about current and future uses for these materials. Mm-hmm.
Absolutely. So I think what we have currently is the materials that come out of our process, which are essentially the carbonated residues. We seek to replace virgin materials with those. So when you look at aggregates, which is what we call them in the most general form for the building industry, these aggregates can be used in ready-mix concrete. These aggregates can be used as substitutes in block formulations, so bricks essentially that houses get built with, can also be used as dispersants for things like fertilizers, which are used. And of course, the added benefit there is that, first of all, they are carbon negative, because they have captured CO2, and they also have a lot of avoided carbon versus their virgin counterparts or substitutes. But then there is really a journey that you go on in terms of actually qualifying those materials for reuse, because typically what you do see is that a lot of the industries where you'd like to reuse the materials that you now have, you see that the specifications and the regulatory environment which surrounds some of those industries has not at all been designed in terms of reusing materials and operating or accompanying a circularity material that's used from a waste stream. And so you are, on the one hand, trying to approve these materials with actual users, but you are also essentially trying to help create a regulatory change in those markets and with those regulatory bodies to ensure that your materials can be reused. And they don't necessarily have any specific drawbacks or differences which make them, weaker in performance. In many cases, they're stronger in performance. It's really just that you're trying to slot a new type of material into an existing formulation. And that's always a challenge to go through in terms of product management and product stewardship. But I think that ultimately the benefits, certainly in terms of carbon footprint and some of the advantages the products have, they do outweigh some of the drawbacks. But it's always a question of a wave that needs to start moving with, a first entrepreneurial user that says, yes, I'll use that. And then a second one, it's a bit like sheep over a hedge, if you will. Once the first few are moving, then typically the whole industry starts moving.
Yes, and it's really exciting to watch how the whole new way of working across the supply chain, how these new ways are emerging, and essentially it's a new market that is being developed. So it's really commendable, all the efforts that you're doing. It's really great. The other questions that would be interesting for our members to learn more about is, what are some challenges and issues that those industrials bring to your door? We often hear of how much on-site space do you require, and let's talk about investments and also the type of CO2 offtake that you can process. So maybe you can talk us through this.
Yeah, no, absolutely. And we focus on a variety of industries, like I mentioned before, whether it's steel, whether it's cement, biomass, paper and pulp industries. And all of those industries come with different challenges and different ways of looking at, first of all, the role, of course, that ESG plays in what they do, but also the scale in which they need the technology to work. So, for example, a paper and pulp producer usually needs a smaller type of solution to try and sequester carbon and treat residue materials. But if you're talking to, for example, an oil and gas major, well, an oil and gas major, wants to look at solutions which sequester at least 1 million tons of CO2 per annum. So the scale at which you are speaking within different industries are very different. And you have a product which you, of course, try to standardize because you want to be able to, operate on as low a cost as possible in order to scale as quickly as possible. You can't make a specific product in the beginning which is completely tailor-suited to every industry. So I think finding the right match between the customer and the industry and what it is that we can provide and what it is that we can treat is a challenge in itself. Although there's no shortage of customers to decarbonize. So I think those drivers are different in industry. I think scaling the technology, really. So currently we operate really in a modular containerized format because we wanted to be able to deploy our innovation and our container, as it's called, everywhere across the globe. One of the things that we see strongly at the moment, certainly from heavier industry and hard to abate sectors, is that people really would like to investigate with us what the potential is of scaling the technology up to independent plant levels. And that pull is coming specifically from oil and gas. It's coming from steel. People that really want to look at the technology as a real solution to carbon emissions. Because if you look at our technology in itself, we capture the containerized format in a sense captures probably anywhere between 1,200 and 4,000 tons of CO2 a year. And then uses that CO2 in the circularity process that I've commented on. But essentially, if you look at that in the grander scheme of things, 1,200 or 4,000 tons of CO2 a year for a major industrial producer is, essentially not solving a huge problem. Just if you look at carbon emissions in an isolated format. With us, it's really the whole circularity solution that we bring that adds a lot of value in terms of ESG. But if you look at it just in isolation in terms of carbon sequestration, we cannot decarbonize an entire cement plant, or even less so an oil and gas plant. So I think with us, I think the containerized version of it is very much a sort of evolved proof of concept almost, but I think ultimately where we will want to end up at is very larger, a lot larger centralized plants and working with industrial players to get there. I think that's ultimately the end game.
Yeah, that's the next stage. And my last question would be, Maarten, is that according to the International Energy Agency's Sustainability Development Scenario, CCS grows by 100 times in the next generation. They give us figures of existing capacity, which is 0.04 gigaton a year, and the capacity under development, which is 0.13 GT per year. So how do you assess this? What's the timeline to add scale storage of CO2 this way?
Yeah, that's an excellent question. I think it's going to depend, on a lot of things. I think certainly there's a lot of work to be done, and I think it's going to take a lot of pieces of the puzzle in order to solve that problem. I think CCUS is part of that solution. I think that we are part of the CCUS space, but I really hope that we will see a lot more mature technologies come into that space to help us solve that problem. I think the challenges are really, they're really across different aspects of the value chain. I think it has to do with the regulatory environment, things like carbon pricing, which help stimulate, business cases for adoption, the costs of the technology and how quickly they can scale and bring costs down. I think all of those things are really important to customers, because what you see currently still is, even though we see that in a lot of industries, major commitments have been done in terms of achieving net zero, either by 2030 or by 2050. What you do still see is that when you come and present these type of deals or these type of offers to customers, they are still looked at very much in a classical sense. And by a classical sense, I mean, is what is the return on investment of these products or deals when we come with containers, for example, to people. And that's where you see, on the one hand, and that's why I think the responsibility needs to sit as well within the industries and within the emitters, is it's very difficult to digest a deal in a classical sense for something which has ESG drivers, which are very, very different. Because it's very different. It's very difficult to put a number on that, although companies are increasingly, I think it was Volvo recently in the news who committed that they're having now an internal price, an internal carbon price, which I think they set somewhere at, I think it was $100 or €100 per ton. So what I think we really need is companies to start publishing data like that helps accelerate the business cases and the adoptions for these types of technologies in order to move them forward and to make them palatable and digestible and adopt.
Yeah, really great thoughts there. It's been a real pleasure to meet you, Maarten. It's a fascinating conversation. I'm sure lots of useful thoughts and ideas for our industrial members. We've got a lot of cement companies and steel and mining, and I think they might look at this as part of the solution for their decarbonization efforts, and hopefully they will get in touch with you. You can also meet Maarten's colleagues, or maybe Maarten himself as well, in our next meetup, which is 28th of April, and ask them more questions and see if accelerated carbonation technology could be the answer for what you are trying to achieve at your manufacturing sites. It's been really great, Maarten. Thank you so much.
Thank you, Aya. Thank you for having me, and look forward to seeing you all very soon.
Same here. Thank you.